Morning, everyone. Welcome to the latest iLinks Insiders event. And I was going to have join with me Mike Peterson, one of our systems engineers, and he may still join, but we're having some technical difficulties. So I may fly solo on this one. And if he can join, we certainly want him to join. We have a little sound issue. Um, before I get in, I want to just set the stage a little bit about what we're going to talk about, and that's really around generative AI and specifically large language models. And the reason why I thought it was really important to have this session is because there's just so much information out there. A lot of it is either just way too high level and not really actionable, or it's way too deep and technical, and it doesn't really forces people to go into the deep end of the pool, as I like to say, and it's really incredibly difficult to understand all the nuances and everything. So the purpose of this session is to just give you a little bit deeper understanding. Hopefully, you'll take away from that, and especially how you could potentially apply large language models, that era element of generative AI within your business processes. So without further delay, I'm going to go ahead and bring up a presentation and talk through some of these slides and give you a little bit more background on it. So, all right, and we'll put this in presentation mode. So that's us. That's the iLinks user community. And before we get started, I really thank you for every one of you that are joining live. And if you're watching this as a recorded session, I highly encourage you to subscribe to our channel. You can go to our YouTube channel and subscribe there, or you can subscribe to the user community within LinkedIn. Again, the focus on these are really digestible nuggets, information nuggets, whether we're talking about topics or sharing information about iLinks specifically, tips and tricks and advanced previews and things like that. So we really, really enjoy and need your participation. We thrive on it. This session will be recorded as the other ones have, and you'll see a link in our user community as to when that will be posted, most likely later today. And again, from a technical perspective, there might be a slight broadcast delay, but everything should be good. So if you want to chime in or anything like that, we really welcome the interactivity. All right, so let's get on to it. LLMs within process innovation. So large language models, we're going to cover a number of different things in a very short amount of time, starting where generative AI fits within the AI landscape. I think it's really important to just have some perspective and context of where this has come from. We'll talk about large language models specifically. Then we're going to get into some of the newer elements regarding where it's going, juxtaposing ChatGPT with some of these custom GPTs that you're likely reading about. Then we're going to talk a little bit about the consistency and how you can deal with that. And then last, we're going to leave you with some examples of some real business problems that we're working on. All right, so the AI landscape, the reality is you're already using machine learning, and some examples of that. Optical character recognition, otherwise known as OCR. This is machine learning that has been trained to convert images of text into actual computer or machine readable text. That's an example of machine learning. It's not learning and adapting in real time, but it's something that's already been trained to do that. And if you use iLinks Advanced Capture, you are taking advantage of artificial intelligence and specifically machine learning already. Document classification. This is another document-centric machine learning set of algorithms. And focus of document classification is analyzing and training a system on how to recognize and discern one document type from another. Really important when you're dealing with intake of a lot of different documents. It could be for benefits or claims management. You've got to find and know what types of documents you have before you can do anything with them. And that's an example. And then here's another one that you're probably not using from a business perspective, but I'll bet you're using it if you have like Google Assistant or Alexa, and that's natural language processing. And this is where we're going to really dig in. This is a system that analyzes text. It can start out actually as audio, and then it's converted into a transcript, and then it analyzes that text to understand, the grammatical features and try to, really distill what the nature of that text is all about so we can interpret it. So the strengths within machine learning, and this is definitely still existing within the generative AI area of it, is it can just process just tons and tons of information, a lot more information than you and I could do, and it can deliver, it can analyze and identify things that humans, or at least the regular ones like me, wouldn't be able to see because they might be so minute we would miss out on them. So the level of detail and the fidelity is just that much there. But with every strength, there's always a weakness. And the answer is, machine learning in general is still data hungry. We're doing a lot of things to lower the bar in terms of how much information you need. There are things called transfer learning. The idea is we pre-train algorithms and then use them on other types of similar problems. But the reality is it still needs a lot of data, at least initially, to create these algorithms or in practice. And the other thing is that oftentimes it's not very easy to understand when something goes wrong. I've been in the AI space for, 15 years now, probably longer than that. And one of the most common questions from clients of ours in other companies is, asking, why did it do this? Why did it output this type of information? And the answer is the reality is we often can't understand or answer those questions. That's a thing too. Now, when we talk about generative AI and specifically large language models, we're talking a lot about the natural language processing domain. So let's move into another little topic and provide a little bit more context in terms of the types of machine learning again. So within machine learning, there are three types. One is unsupervised learning, another one is supervised learning, and then there's a third called reinforcement learning. So let's take a little bit, dig in a little bit more about that. So let's start with unsupervised learning. Unsupervised learning is really all about taking information and trying to distill attributes of this information so that we can do things like grouping or what is called clustering. So it's not uncommon that we can use, or it's very common that we can use unsupervised learning in the vein of clustering to automatically group information by likeness. It can be images, it could be pictures of documents, it can be other types of things. And the idea is that by grouping by likeness, we get a little bit more insight in terms of what that information is all about. Now, the supervised learning portion of machine learning deals with providing the system with additional information, additional context as to what we're expecting the machine to be able to produce. So we typically term that as tagging or metadata. So in the case of document classification, which is a supervised learning type of algorithm, we provide it with a sample set of documents along with their tags of what the documents are. And from there, the machine learning algorithms will learn to distinguish, finding things like called features or attributes that help it to reliably distinguish one document, let's say it's a contract, from another one, let's say it's a claim. And so that's an example of supervised learning. We're providing it with the answer key. And then within the domain of reinforcement learning, that's where we look at the feedback and then provide it with basically how well it did. Did it do a great job? Is it accurate? Is it not quite accurate? Is it completely inaccurate? And it can use that type of information to adjust and modify what are called weights within the machine learning models. And the idea is that it gradually improves and it can learn. And in a lot of cases, it can do that with reinforcement learning. Kind of the state of the art is it's taking information from the environment. It's not specific. It's really important when we talk about generative AI to understand that it actually uses all three types of machine learning. So it uses unsupervised learning initially to examine text and try to understand attributes. It uses supervised learning where we're trying to fine tune the models, and then reinforcement learning. If you've used ChatGPT, you can actually say, hey, you did a great job. That's an example. So let's get into generative AI, and I really like this definition provided by McKinsey. It's a branch of machine learning that involves algorithms that can be used to create, and this is the big thing, new content. So unlike OCR, document classification, where it's providing answers It's basically saying this word is transcribed from an image into, let's say, start as an answer, or it's providing a document class as an answer. Those aren't really new content. Generative AI actually can produce new content, so it can summarize things. It can create articles and things like that. And within generative AI, there are a number of modalities. So modalities being the types of information that it takes in and the types of information that it produces. So you can imagine with ChatGPT, that's text, but we've also got Stable Diffusion and DALL-E that deal with both text inputs, but also image outputs. And even more impressive and interesting are the areas where we deal with audio and video. So it can produce actually animations and things. So it's really interesting. But the text generation domain is really where we're sitting, and where we see a lot of benefit, especially when it comes to process innovation. So those use what are called generative pre-trained transformers, or otherwise known as GPTs. And that's just a little crappy image of something I use. And it's kind of an example of really the quality of the input, those prompts, how you deal with them really, really, you've really got to get a high quality amount of input to get really good quality output. All right, so digging more into these language models, it's really all about understanding natural language. And the general scientific community and computer science community has been trying to do this and working on this for, gosh, half a century, if not longer. Starting way back with ELIZA out of MIT, which was a more of a rules-based type of natural language processor, but it still made people think that they were talking to a human. And then it moves forward quite a bit. And if Mike were here, he would say this was really enabled by access to large amounts of data, as well as significant computing power. So as we progress and had access to more information via the internet and all the information that's published there, as well as cloud computing and access to just tremendous amounts of computing power, including GPUs, we're able to just push the envelope in terms of how we can enable systems to take input like language and understand it grammatically, and then understand and interpret the meaning and the intent around it. And then the generative side is to create models that still work on probability and statistics to produce output that's very, very human-like. So this is not just something that happened in November of 2022. This is something that started way, way back in the 60s. So it's really important to understand when we're talking about large language models, it's really this significant evolution of natural language processing. All right. So let's dig into the chat GPTs that we all know about, and then these things called custom GPTs, because we're starting to narrow the focus that allows you to start using this type of technology and capability to solve real problems in a very reliable way. So when we talk about chat GPT, we're talking about, and these other large language models where people are most familiar with them, with their ability to produce just amazing output and answer questions. It's really about asking questions and those prompts and getting output that's based on the information on which it's been trained. And ChatGPT has been trained on trillions of examples of text, and it's been able, and so it's got all of that information. Not only does it know how to respond, interpret text and language and respond in a very human-like way, but it's got access to all that information that it's been trained on, so it can answer questions too. But it's very broad-based, and so with that comes some risks, and you might know it as hallucination. Those are the instances where you ask a question or you ask it to do something, and it produces very real-sounding information or responses, but there's some factual problems with that. So this is an example of a simple LLM query where we've got the user, and you've got this prompt, which is the input, and it goes into this generative language model to interpret and understand that language, and then it goes back to its training data set. And it's basically, I think, most recent, I think the ChatGPT updated to 2023, in terms of the recency of the information, and then it provides an answer. So that's great. And it's pretty exciting in terms of getting things to a state where you can ask it a question and get something pretty interesting in terms of the answers. But it's not really good enough when you're talking about using it in a more reliable way for your organization or businesses. And this is really where custom GPTs are employed. And what it's doing is, in most cases, it's using something called retrieval augmented generation, or RAG, to focus answers on specific corpuses of data, very narrow set context. And the reason why we do that is to reduce the variability of answers that it would have, and to focus answers on specific domain. Let's say you've got your organization has a frequently asked questions site, and your customer support group often gets a ton of different types of questions that it has to look through a knowledge base and find this type of information. And you want to make this a lot more proactive, and you want to put that information out and enable people to actually just ask questions like they would a customer support rep. Then you would narrow the scope on only the data within that knowledge base of questions and answers. And we do that through something called retrieval augmented generation. And what it does is it significantly reduces the chances for hallucination or the bad facts. And it also helps you to focus the answers on specific areas. So there's the variance, it's going to be focused solely on answering questions associated with that knowledge base. So here's an example, and there's a lot more involved here. So the user would still have that prompt, but what happens is before we've even done that, we've created a knowledge base that the large language model can consume and use for reference, so that when a question is asked, it's only going to go, or it's supposed to only go, to that informational database that it's drawing upon. So it's going to understand the question, go there, and then attempt to answer the question solely out of the information provided with that knowledge base, and then return an answer. And if it can't find an answer, we can tell the large language model via some sort of parameters to basically say, I can't find an answer. So it's not going to try to be creative and make something up. And this is really, really the thing that's exciting to me and to us at ImageSource, because it allows us to take the large language model and its ability to understand language and produce output that's very human oriented, but focus it on solving specific problems within a specific domain and do it a lot more reliably. So let's talk a little bit about how you would do that. And I'm going to get into a little bit of tech stuff, but just stick with me. I'm not going to drag you too far into the deep end of the pool. So you start with the large language model. So you do have to have a large language model, and there are a variety out there. OpenAI is just one variant, but Google has its own version. There are open source versions provided that you can find on a site called Hugging Face. There are other incarnations by Anthropic, and it seems like every month there's a new large language model. So you have that as its foundation to understand the input text and generate things. But what we've done before that is we've taken your data. This could be in the form of all sorts of help aids, documents, knowledge bases, and we're taking that information. It could be any type of unstructured information. And then we're going to pull it out of those systems and parse it and do what is called tokenization. Now, what that means is we're going to do things like parse that text. We'll convert it to text if it's an audio or video, and we're going to tag it with parts of speech and give it all the grammatical flavor that a large language model would need to have. So it's adding and enriching that data with all of those types of things that aid with natural language processing. And then while it's not shown here, we're going to put it and put it into a vector database. And what that means is we're going to process each of this tokenized information and help the large language model understand what are responses or likely responses that are going to be more statistically accurate than other ones. So it's doing a lot of really, I guess you could say it's more complex things, but it's really conditioning that information so the large language model can pull from it the more accurate answer than something that's inaccurate. And then of course we've got the the actual GPTs or the different types of variants, which are actually doing the processing. They're understanding the input. They're going back over to the information store that we've created, and then they're producing an answer to do things like question answering, reading comprehension, language completion, any type of thing. Copywriting. It's quite possible to provide as a knowledge base all of your marketing copy and every bit of marketing literature for products you have, and have it produce new stuff that focus solely on your product. So this is really the key place that we're focusing on now, is creation of this infrastructure and helping organizations understand what content repositories they have to start with, conditioning those and making sure they're of high quality, and then doing all the parsing and vectorizing so that it's ready for a large language model to be used for things like chat, producing answers and things, whether it's internally oriented, like a helper aid for a customer service agent, or something that's more direct to a constituent or a customer, and answering and finding the information on their own. So this is just amazing work that is being done, and I expect, and we all expect, for this to be, for new ways of narrowing context and providing highly accurate answers just to continue to flourish. So let's get to the meat. Examples of large language model applications that you should explore, you should consider, and we're definitely exploring. So within image source, we're looking at, and especially within the generative AI side of things, we're looking at two areas: content understanding and content generation. Now, content understanding is really, and how we define it is, it's really about understanding information within unstructured data. Unstructured data meaning documents or audio or video, and extracting the facts so that you can use them to shepherd things like cases or transactions. So it's really about extracting those facts from hard to process documents. So imagine in case management, you're intaking a new case, and you've got basically 10 or 15 different types of supporting documents that you've got at your disposal that are submitted along with it. Content understanding can go and rifle through and parse that information so that it's pulling out specific information that you need. And it can do it not only for structured forms, but really, and more interestingly, it can do it for complex information, such as contracts. We're actually working, and we'll show you later next month, applications that involve parsing very complex information like data within college and high school transcripts. So it's really about getting those facts. And within the content generation area, it's about taking and synthesizing this information. So one example might be, using that case again, is taking all these documents and summarizing the information within it so it's easy to digest and we can get a good feel for it. That summarization might help us understand we can take that information and run it through predictive analysis to identify whether or not that case is likely to go off the rails, and you want to do something before it even happens. So summarization of the facts. Another case is a synthesis of a variety of information. So in one that I happen to like because it's interesting is within lending, or especially mortgage lending, where you've got potentially hundreds of different documents, is being able to go through those and synthesize and summarize various amounts of information so that you can get it in one place, and arguably in one page or virtual page, so that you can get into the system. So it just cuts down on a significant amount of work that most often requires very, very manual processes. So I like to consider it's generating insights regarding the facts. And again, by narrowing the context, by providing a database for the large language model to dip into and reference, we're able to provide a much higher level of fidelity of output and accuracy of output, and also creating more consistent output, because rather than making it highly variable like what you would see in hey, generate me copy or market, something very interesting, we're wanting the specific information. We want the facts. We want the summary, we want the analysis, but we want it to be grounded with the facts that we're dealing with and with the information that is most important to us. And so that's not the historic baseball averages of major league players or anything like that. That's way outside of what we're interested in. It's really about getting things done through real process innovation. So hopefully, as we've gone through here, you've gotten a better sense of how generative AI fits within the AI world, specifically within large language models, how they work, where they're going, that they're very useful, especially as you move into using RAG to narrow focus and just really amp up the fidelity of information and the reliability of that information. And I want to leave you with some links here, and I'll provide these, obviously within the recording, but these are some really good reads, starting with kind of the general introduction to large language models, and then going deeper all the way to Stephen Wolfram's large treatise on how ChatGPT and GPT models actually work. So I found these very interesting. You might too. So again, I want to thank you for attending this session. And if you have any comments, please leave them in our community. Feel free to send me emails, chats, reach out to me on LinkedIn, and be sure to tune in. We've got in a couple of weeks, Image Source, we are going to provide you some details about iLinks AI. It's really about taking AI and making it useful for your organization today. And some of the things that we talked about today are absolutely going in there. And then we're going to have another Insiders session late February that shows you some actual demonstrations of our work. So thank you very much and have a great day.